Section 2.4 is on statistical graphics. By the way, let me just tell you what you're in store for when you read through this section. There are 10 or 12, I forget, different examples of different ways of showing data graphically. 10 or 12 different ways of doing it. You do not have to memorize all the 10 or 12 different ways to do it. That's not the goal of this course. But the goal of this course is to kind of expose you to it and get you an idea of how some representations can do one thing and how other representations may do another thing. And to give you an idea also of just how to read, different ways of representing data. That's what you guys need. So when you see some kind of graphics, you know how to deal with it. And we've already had examples. Now this one we haven't had yet. It's called the scatter plot. But you may have had this in an algebra course. I don't know. How many of you have seen a scatter plot before? Really? Cool. I'm going to make one right now on the calculator. I'll show you how to do it. Your TI calculator you have can do this. Maybe you know how to do this. This may be very much review, but see, if I hit the y equals screen right now, I don't want to go too fast, so I'll let you catch up. The calculator's on, and this button right above the second says y equals. If I hit the y equals screen, if I'm in an algebra class, you probably did things like, oh, let's graph 3x, maybe you did 3x squared plus 1, and you hit the graph button, and you got pictures of curves. A parabola, that's right. You guys remember nightmares? No, I mean, remember some of this stuff? Okay. Let me go back to the y equals screen again. I'm going to delete this stuff. Do you notice up above there's something that says plot 1, plot 2, and plot 3? Those are more often used for statistics. They're also used for the games that come on these, so just so you know. But anyways, I'm going to hit the stat button here because we're in the statistics here. And so you see where that is for me is right below the delete button. And it says I can edit or calculate or do tests, and we will use all these functions throughout the course. What I'm going to do is I'm going to edit. And now it gives me some lists. Okay? So I can make a list of certain kinds of data. Now I guess I'd have to pick what I want to do. Example. I'll tell you, let's take the example right from the book. Let's do that. That would actually be worthwhile to see how it goes in the calculator. So, Chapter 2. Uh-oh. Thank you. Example 9. Oh yeah, that's classic. Page 64. But actually, let's move ahead. Let's move ahead to page 69. And one of the exercises I assigned for homework, I believe, is problem 22. Oops, that didn't work. So let me give you a little help here setting it up. Problem 22. Okay, so problem 22 says, refer to data set 12 in your book. And it says use the 22 average daily temperatures. And what's that? And the 22 corresponding amounts of energy consumption. And one thing that's important is when you look at data, it's important to know what the units are for the data. So I guess we have to look back where data set 12 is, huh? So let's see. Data set 12 you can find in the back of the book on page 790, oh no, 780. Okay. So the daily temperatures back there are listed in degrees what? Fahrenheit. And the corresponding amounts of energy consumption, those are listed in kWh. Do you guys know what that stands for? Kilowatt hours. So kilowatt is power, but then 1,000 and then per hour. Okay, so this is yeah, it's the amount of energy. That's the units, and you know, it may not matter to us right now what the units mean. Okay, but at least I want to keep track of them. Okay, so now what do we have? Well, we have that when the temperature was 29 degrees, the average daily temperature, it says in January and February, we used 3,637 kilowatt hours. Then in March and April, the average temperature went up, and notice that we used 2,888 kilowatt hours. Now, does that make sense to you? That we would use less energy? Yeah? Right. Right. On the colder month, maybe you have the heater running more, right? Let me throw another one on there. They say in May and June from that year, it was 57 was the average daily temperature. And now it was 23.59. And then July, August, the average temperature was 74. Oh, look at that. There's an explanation maybe. Maybe air conditioning is kicking in those months, right? Okay. Well, there's 18 more points to plot, but I'm not going to do that right now, okay? What you'd have to do, if you wanted to put this on your calculator, is let's show you how this works. Okay, so again, I turn it on, I hit the stat menu, and I edit. I'm going to edit my lists. And for me, list 1 is going to be the temperatures. And I think there's even a way to change the name. But I'm not going to do that. I'm just going to go ahead and type in the data. 29, 37, 57, and I'm just hitting enter after each one, and 74. And then once I have all 22 of those in there, I can hit list 2, and let's see, we'll put 3637, 2888, 2359, and 3704. Okay, so I have the data in the calculator, and I want to do what's called a scatter plot. First of all, any questions up to this point? All right, so I want you to watch carefully. I want to go through this once. So I'm going to hit the second button and then hit quit, which is right next to it. This mode above it says quit. Second, quit, because I'm done entering data. Now the next thing I want you to notice, see the y equals screen? Well, see the y equals button? Above it, in yellow, it says stat plot. So I'm going to hit second and then y equals. And it says plot 1 is off. Well, I want to hit the enter button because I want to work on plot 1. And I'm going to turn it on. That's one thing I'm going to do. So where it says on, I'm going to turn it on. And then if you move with the down arrow, it says what type of plot do you want? Now, by the way, this very first one that's listed, that's a scatter plot. That's the one I want. By the way, you might recognize this one that's over too. Do you recognize that one? That's a histogram. This guy can do a histogram. If you just have one list of data, matter of fact, let me click on that just to show you. If I click on histogram, it could do a histogram for list 1. That would be meaningless right now, but it could. But we want a scatter plot, and a scatter plot uses 2 lists. And it does the kind of graphing you did in algebra. It plots the points. And it's going to mark them with a square the way I have it now. When you're all ready to graph, here's how it works. The best way to do this is to use this key called zoom. If I hit the zoom key, if you hit zoom standard, that gives you the 10 by 10 screen you normally get. But then we'd miss all the data because our numbers are huge. You guys see that? I mean, we have thousands of kilowatt hours. So I want to move down to where it says zoom stat. For me, that's choice 9. I don't know what it is for you. And I'm going to press enter. And that'll zoom and give you a picture that allows you to get all of your data points. So I got 4 of them up there so far. If I hit the trace button, I can move from point to point. So this one is 29, 36, 87. If I hit the right arrow, 37, 288, 57, 23, 59. Okay? This is a way of producing a scatter plot on the TI calculators. We will use this semester throughout the course. Okay. Something called a dot plot, something called a stem plot. Debatable. Do I want to do that now? That I think I'm going to have you read and do next time. Because I think it's more important right now to do this. I want to go over 2 problems from section 2-2 that you did for homework, okay? So let's talk about problem 6. That was one of your homework problems. You didn't have the answer for that one. All right. And the nice thing is that while I'm going over it, I can also, teach you something. That's the point here. Okay. Let's do problem 6. Problem 6, they give you a chart. They say, okay, here's tar, milligrams, and these are for filtered cigarettes. And they give me the frequency. And so they tell me that in the 2 to 5 range, I have something. In the 6 to 9 range, we had 2. In the 10 to 13 range, we had 6. But most of these cigarettes had 14 to 17 milligrams of tar. Fine. Okay. Now, by the way, what's this thing called? A little vocab quiz. Frequency distribution. Thank you. If you have a frequency distribution, like we do in these sections, what kind of graphic do you already know how to draw? What's that? We know how to make a histogram, and I'm going to do that with you now. That was something you guys had to do. So let's see. I guess I would do it this way. I would put some numbers down, and let's say here's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. And then let's see. Starting at 2 here, in the 2 to 5 range, we had, and then the y-axis here, I guess this is going to be frequency. So I don't know, I guess I'll go 5, 10, 15. So in the 2 to 5 range, we have 2. So I guess I'll go that high. So really I should go up to 5.5, because remember that's the boundary. like if this is 5, remember that the boundary is at 5 and a half. You go a half either way because we want to be in between 5 and 6 for the actual boundary. Okay? I guess I started at 1 and a half because I wanted to extend out the boundaries so that all the classes would meet, all the bars of the histogram would meet. I actually moved down to 1 and a half right there. Okay? So that might help because otherwise these bars won't quite be touching. And in a histogram, we really want to account for every possibility here. So then from 5 and a half to what? To 9 and a half, we also want to be at 2. So that looks to me like that would bring me about there. All right. And then in the 10 to 13 range, it's nice to have multiple colors. Yeah, I want to go to 13 point, but I want to go up to 6 for this bar. So there's 13 and a half or something like that, somewhere around there. And then, yeah, the last bar, we want to go out to 17.5. So I guess, let's see. That's all the way up to 15 for that frequency. Why? Okay. That's where I started. Okay, well, we have a question. Let me enter for 1 second. The question was, why do we start at 1.5? Again, I wanted to extend out a half from each of the class limits. It wasn't so important here on this side, but it was important here that I extend out so that they meet. So instead of being at 5, I actually went out a little more to 5 and a half. Well, since I went a half this way, I also went a half that way. Okay. Now back to Annette. I'm sorry. Go ahead. You were asking me. Oh, you didn't do a histogram. Yeah, I guess you didn't have to do a histogram for this problem. They didn't tell you to do one. Right. Why am I doing this? Because later, you guys did have to do histograms, right? This is the procedure. I thought maybe that would help some of you that were struggling. Did some? Yeah,
So
David?
whenever we start on a histogram, we start 0.5. Like if it's like a 2, we start like 0.5 under it.
Yeah.
Go up.
Well, you want to meet at the midpoint of the 2 class limits. That's right. That'll be the class boundary.
So you always start at
And so,
half before it and a half after?
well, if they're 1 apart, then yeah. Now, if they were 10 apart for some reason, I would move halfway in between, like 5.
But you can still start.
But yeah, you start, the boundaries are there, yeah. Can I do one last thing with my last minute instead of get that question? Okay. The thing I wanted to show you is this. There's something called a frequency polygon. You'll read about this today. And here's how it works. You take the midpoints of each of the bars of the histogram. So I need a nice color here that I haven't used yet. I've used like everything under the sun. Here we go, orange. All right. So what's the midpoint of the first class? Between 2 and 5. 3.5, right? 3 would be between 2 and 4, so 3.5. And I'm going to put a little dot right there at the top because the frequency there is 2. Or between 5.5 and 9.5, I'm sorry, between 6 and 9, the midpoint is at 7.5. So right about there. And between 10 and 13, we're at 11.5. Right about there. And between 13.5 and 14 and 17, I'm sorry, we'd be at 15.5. No, 16.5. Nope, 15.5. Yeah. 15.5. Now watch this, guys. If I connect these orange dots, and then I bring it down again, you want to bring it down to what would be halfway between the next class if there was one. Okay? If you connect that, see that orange line? It's a funny graph. It's called a frequency polygon. And you'll usually draw it without the histogram there. Okay? But that's one of the things you'll be reading about. See, there's all kinds of statistical graphs. And again, we're going to get exposed to some of these before Thursday. We'll talk about some of it on Thursday also. All right? Thanks, guys. What's that? Colored pencils might help, yeah. I mean, they say color is a great thing for graphs, you know.
I was going to stay
Uh-huh.
after your thing on the frequencies. I really think
That helps?
somebody will bring it in.
Oh, cool.
They'll bring it in.
Okay.
Check on that.
All right, cool. Well, I'm glad I did one. That was worth doing. Okay. Yeah, critical thinking, bad graphs. I want to show you guys, start by showing you guys a picture that you saw before in this class. And then show you one that you saw maybe last time. See, the key concept from this section, well, okay, some graphs contain errors because that you just screwed up, right? But also, some are bad because even though they're, quote, accurate or technically correct, they can be misleading. And that's what this whole section that we did for homework is trying to get at. So, when we started Chapter 2, I had you look at, and also for Chapter 1, I remember we spent one day in here where we talked with a partner about the very first page of the chapter. The first page of Chapter 1, I remember, was about the, what was the name of that magazine? The Literary Digest, and what was wrong with their poll. And then here's what you saw at the beginning of Chapter 2. The graph on the left. Figure 2.1. And then here on the right is what you would have seen in the reading last night. Do you guys see those two graphs? Do those two graphs have the same information on them? Right? 62% of Democrats wanted the Shibos feeding tube removed. 54% of Republicans said they should remove it, and 54% of the independents said they should remove it. Okay? And that information is contained in Figure 2.1, and that exact same information is contained in Figure 2.9. But do you agree that these two pictures tell a different story in a sense? I mean, which one makes it look like, let me ask this one, which one is misleading? What's misleading about it? Yeah, that's the way that the book says it. They talk about what's the baseline of your graph, right? Here we start at 0, and here you can see from the graph about how different the opinions of Democrats and Republicans are. I mean, we're talking an 8% difference, right? But if all you do is you show the tops of the bars, boy, does it look different, doesn't it? And this is done all the time in the media. I encourage you to, before Thursday, before we meet again, take a look around at whatever media you use for your information you gather, your news. And I want you to see if you find any graphs that are misleading. Actually, if anyone has them and wants to share them, that's great. If you have electronic format, we can put little links on our webpage, on our Blackboard page. If you have newspaper, bring it in. Because you'll find this all the time. You know, sometimes people are trying to be misleading without actually lying. That's what this may be. It's either that or they're just not doing a good job of representing their data. Okay? So this is the kind of thing we want to look for, and that's one of the things that the exercises had you look for. Here's another one that the book gave, and I kind of like this example. Annual incomes of groups with different education levels. Okay. Now, okay, what's misleading about this? Well, when you ask what is someone's income, they give you a number. A number is somewhere on the number line, right? That's one dimension. Two dimensions is if you have like an x-axis and a y-axis. But how did they make the data look here? They made it look three-dimensional, right? Like we're filling our boxes full of money. But now wait a minute. 18 times 4 is 72, right? So if you have an advanced degree, that figure is about 4 times bigger than this figure. But if those were actual boxes, you could fit a lot more than 4 of those in here. See that? Seems to me like what they did was, maybe they took this length and said, okay, let's put 4 of them here. 1, 2, 3, 4. And had they done that, that'd be fine. So, for example, a histogram or a bar graph, in a sense, actually, would be fine. A Pareto chart, we call it. That'd be a fine way to represent this information. But when you start doing this, well, if you did 4 times 4 times 4, 64 of those boxes would fit in a box this size. That's not an accurate representation of the data. Okay, so I like what they show you as some examples here that are misleading. So yeah, now I did want to talk about homework questions for a little bit. Okay. And my plan was to actually write this stuff down so you could look at it later, but my pen isn't functioning, so we're going to can it here. And I'll just do whatever we need to on the board.